Hello. This video is going to be on double replacement reactions using your solubility table. So remember, one side of this sheet is your activity series for single replacements to determine if those happen. This side we will use for double replacement reactions. Okay, and it's on solubility. So solubility just means does something dissolve. Okay, so this list is mostly talking about ionic compounds, a metal with a nonmetal, usually a polyatomic ion involved in this. So again, solubility just means will or will not dissolve. So you know that salt dissolves, sugar dissolves. So remember, when those things dissolve, you can't see them anymore. Okay. In this bottle right here, I have dissolved some salt. Okay. You can't see the salt. You can see right through there. In this container is some iron chloride. You can see the color, but you don't see the solid iron chloride in there. Now in this is some silver chloride. Okay, that's an insoluble substance. It's sitting at the bottom of this. Some of it's suspended in the solution, but it is slowly settling to the bottom. It's insoluble. If I stir it up, it will just settle back down to the bottom. It's an insoluble compound. Okay, so when we do double replacement reactions, if they produce a precipitate, we figure out what the precipitate is. The precipitate is the insoluble thing. Okay, so we're always looking for a precipitate on our double replacements. It's always the insoluble thing. Now, some double replacements don't produce precipitate. That's considered a no reaction or ain't none reaction. So here's how the table works. If we look at it like this, any compound that has lithium, sodium, potassium, rubidium, or cesium in it is always soluble. So that means if I have lithium carbonate or potassium hydroxide or sodium sulfate, okay, any compound that has a family 1 element in it will always dissolve. So these will never be a precipitate. Things that are soluble will never be a precipitate in a double replacement reaction. You're always looking for the insoluble thing. If you see this ion in a compound, so like NH4Cl, if you see ammonium in that compound, it's always soluble. If you see NO3 in a compound, it's always soluble. Okay? And if you see the acetate ion, it's always soluble. Okay? So these things up are always soluble, no matter what they're with. Okay? Again, these will never be alone. They're always going to be with something like sodium nitrate, iron nitrate, calcium nitrate. Okay? So those things are always soluble. You get down to fluorine, chlorine, bromine, iodine. So if you see one of these in a compound, fluorine, chlorine, bromine, iodine, they are soluble, but there are some exceptions. So most of the time these dissolve unless they're with silver, mercury, or lead. And I usually just say you need to know silver and lead. So that means like silver chloride will not dissolve. It will be a precipitate in a double replacement reaction. It will sit at the bottom and not dissolve. Okay? Lead iodide will not dissolve. Okay? Or lead bromide, or lead chloride, or lead fluoride. Okay, so things with chlorine in them usually are soluble, unless they're with silver and lead. Sulfates, generally soluble. So potassium sulfate, iron sulfate, zinc sulfate, those things are soluble. Sulfates are not soluble if they're with these ions. Okay, not something you have to memorize, but okay, so as you go down, it tells you if they're soluble or not. Now, you get to the bottom here, from here down, there's a little break right there. Those things are generally insoluble. Okay, as you go down there. So these things at the bottom are generally insoluble. Not always, though. Okay, so carbonates are insoluble unless they're with family 1. So unless you have sodium, lithium, potassium, rubidium. So if you had like sodium carbonate or lithium carbonate, it will dissolve. Okay, but otherwise carbonates are insoluble, or if they're with ammonium too. So these things, if you see them, they're generally insoluble unless they're with family 1 or ammonium. Okay, so you can kind of figure out the solubility rules from there. So if I ask you to predict if things are soluble or insoluble, so like magnesium phosphate. So magnesium phosphate is this compound. So I always look first of all and say, okay, is this a family 1 element? If it is, it always dissolves. Magnesium is not family 1. So now we find phosphates on the list. Phosphates are on there. Phosphates are insoluble except with family 1. I don't have that covered up. Unless they're family 1, they are insoluble. So this compound would be insoluble. It will not dissolve. That means it could form a precipitate. It would be the insoluble thing. You know, you mix two chemicals together, it might be the thing sitting at the bottom there. Silver nitrate. So the first thing I always look at is the first element family 1. If it is, it's soluble, or if it's NH4. In this case, silver is not family 1, so go to the second part. Nitrates. We can't see nitrates right now. I'll pull that down just a little bit. Nitrates, always soluble. This compound is soluble. It would dissolve. Okay, AgNO3 would be soluble, would dissolve. If we look at a couple of these, Na2SO4, again, if you see a family 1 element in there, sodium is in family 1, always soluble. Doesn't matter what it's with. Same thing here. Lithium is in family 1, always soluble. Doesn't matter what it's with. NH4, at the beginning of the compound, always soluble. Let's look at like lead sulfate. So we'd go to first element is not family 1. Okay, find sulfates on here. Sulfate, SO4. Those are soluble, but there are some exceptions. Soluble except with, sulfates are soluble except with these things, and lead is one of the ones on there. So that would be an insoluble compound. All right. So now, if you're writing a double replacement reaction, briefly, I will do just a couple of these. Writing double replacement. So let's say we have a reaction of, let's say we have some silver nitrate with some potassium phosphate. So we got this double replacement reaction going on. Okay, both of these things would be soluble, by the way. Double replacements, the two reactants are always going to be soluble. You're looking for an insoluble product, double replacement. So remember, the potassium and silver are going to switch places. So the potassium goes with the NO3. And the silver goes with the phosphate. These are +1, -1, by the way. And this is a +1 and a -3, so we're going to go there. I'm not going to balance this right now. So these two things are made. Remember, these two things, as the reaction goes, are going away. They're turning into these things. So at the end of the reaction, these two things are there. Well, let's look and see if this is soluble. KNO3. Well, it's got a family 1 element in it, so this is soluble. Okay, this thing would be aqueous. You would not see it. It would be dissolved in solution. You would not be able to see it at all. Ag3PO4. Not a family 1 element, so we find phosphates. Phosphates are insoluble, except with these things. Silver's not one of those. So silver, this would be a solid. That would be your precipitate. Okay, so in the reaction, it would be the stuff sitting at the bottom at the end of the reaction, the silver phosphate. The KNO3 would be sitting up in the solution, dissolved. All right, let's do one more. Let's say we have potassium nitrate with sodium chloride. Everything's a +1, -1 charge here. I made it pretty easy. So potassium is going to go with chlorine, and sodium with nitrate. Well, if you look these up, that's a family 1 element, so that's going to be soluble. It's going to be aqueous, so you will not be able to see it. That's also a family 1 element. That's going to be aqueous. You'll be able to see it. So if you do this reaction, these things are dissolved, these are dissolved, you would see nothing happen. That's called a no reaction in this case. If there's no precipitate formed, that's called a no reaction. Have a good day.